Hello friends, Steve the Math Buddha here, and today we're going to be looking at a new series of mine called Facebook Quickies. I'm in a number of math Facebook groups, and I'm seeing the same questions coming up over and over and over again, so I thought maybe it would be fun to look at some of these on this channel. In particular, this week we're going to be looking at consecutive integer problems. I see a lot of consecutive integer problems on Facebook, and most people jump to the algebra. It's just a natural thing. That's what we learned. That's how we solve things. We write algebraic expressions and then we solve them. But you don't need algebra to solve most of these consecutive integer problems, and that's what I'm going to show you today. I'm going to show you some tricks that will help us all to solve these problems. So let's start with question number 1. Now here's a real good one. Suppose we have a pair of consecutive integers, and suppose we take twice the smaller and add it to 4 times the larger, and we get 94. What are those two integers? Now what I'm going to do is I'm going to give you 15 seconds to think about this, and then I'm going to show you my solution. And your time starts now. Okay, so how many of you did this? Now this is what everybody on Facebook did. I'm thinking because I told you we don't need algebra to solve this, that maybe you all might have tried to find an alternate solution, but I'm guessing a lot of you did this anyway because that's just the go-to. Algebra is the go-to. But you don't need algebra to solve this problem. All you have to do is recognize that twice the smaller plus 4 times the larger has to be 6 times some number in between. All we have to do here is divide 94 by 6 and figure out which integers it lies between. Now I'm going to use algebra to show you why this works, but you don't need algebra to solve this problem. This is just to demonstrate why my methodology works. So here's why. On the left we have 6 times the smaller number. 2 times the smaller number plus 4 times the smaller number is going to be 6 times the smaller number. And clearly this has to be less than this because this is less than this. Now on the right-hand side of the equation we have 6 times the larger number. Twice the larger number plus 4 times the larger number has to be 6 times the larger number. And clearly this is larger than this because this is larger than this. So what we have is that 6 times the smaller is less than 94, which is less than 6 times the larger. Now what we do next is we divide the entire expression by 6, and we get that 15 2/3 is between the smaller and the larger. So our integers have to be 15 and 16. Now again, I did use algebra to show you why this works, but to me it's pretty intuitive. Twice a smaller number plus 4 times a larger number has to be 6 times a number in between. All you have to do is divide that number by 6 and see what integers it lies between. So let's move on to question number 2. Suppose we have 3 consecutive odd numbers and their sum is 129. Find the numbers. Once again, I'm going to give you 15 seconds to think about how you will solve this, and then I'm going to tell you my solution. And your time starts now. Okay, so how many of you did it this way? Now it turns out that this particular question, a lot of people on Facebook were able to figure this out without using algebra. And I'm thinking many of you might have also, especially since I told you we are not going to be using algebra to solve this problem. But I too find it interesting that people always set up the numbers this way, where x is the smallest, and then x plus 2 and x plus 4. Wouldn't it be easier to set up the numbers this way? Wouldn't it make more sense to call the middle number x? Then we have an x minus 2 and an x plus 2. So when we add everything together, the minus 2 and the plus 2 drops out, and we just have 3x equals 129, or x equals 43. The middle number has to be the average. All we have to do is divide 129 by 3, and that tells us the middle number. It's got to be 43, which means that the consecutive integers would have to be 41, 43, 45. Now once again, I used algebra to demonstrate why this works, but you don't need algebra to recognize that the middle number has to be the average number. All we have to do is divide 129 by 3 to find the average, and then we have everything we need. And before we move on to question number 3, let's take a short commercial break. So I'm going to have to break in here and remind you that if you like this video so far, please like and share, and please turn on those notifications so that you know when my videos are coming out. And please, please don't forget to subscribe. And by the way, I'm not sure if you noticed, but I am wearing a new t-shirt today. It's not a new design, it's an old design, but I had it printed in brown this time. I also spaced it a little differently. I shrunk it and lifted it up on the shirt because it was hanging a little low. You could do anything on Zazzle, and as usual, I have a link to the Zazzle site in my description below, along with a link to the Fiverr artist that created the design. Now that's for original designs only. Math Buddha t-shirts are not currently for sale. But if you are going to buy anything at either one of those sites, please use my links because it really does help to support this channel. And now back to our show. For problem number 3, we have a multiplicative problem. Suppose we have a pair of consecutive prime numbers, and suppose the product of those prime numbers is 4,087. What are the prime numbers? As usual, I'm going to give you 15 seconds to think about it, and then I'm going to give you my solution. And your time starts now. Now for this one, I don't actually see an algebraic solution because prime numbers, we don't know what the distance between them could possibly be. But what I do know is that if we take the square root of 4087, it has to be between those two prime numbers. And here's why. If x and y are positive, and prime numbers are always positive, then x squared has to be less than xy, which is less than y squared. So if you take the square root of xy, it has to be between x and y. So all we have to do here is take the square root of 4087 and determine what prime numbers it lies between. And the square root of 4087, you can use a calculator for this. It comes out to approximately 63.92, which is going to be between 61 and 67. 61 is prime, 62 is not, it's even. 63 is divisible by 3, 64 is even. 65 is divisible by 5, 66 is even, 67 is prime. So the two prime numbers that 63.92 lies between is 61 and 67. So that's our solution. And so I have introduced yet another Math Buddha series, the dreaded Facebook Quickie series. I really hope you all enjoyed it. Please let me know in the comments what you thought. Now this video was a little shorter than the other videos that I've done, but I think I'm going to have to do that in the future because my videos have been really involved and keeping up a pace of once a week has been a really aggressive pace to keep up. So I do think I need to shorten these things up and make them just a little bit more basic. Let me know in the comments what you think about that. This is the Math Buddha and I'm signing off once again. I really hope that you have an amazing night. Goodbye, folks.